Hi, in this video, we're going to talk about ketogenesis. So what is that? So it turns out that after fatty acid breakdown, which we saw how it happens, some of the acetyl-CoA is used to make small compounds. So here, acetone, acetoacetate, and beta-hydroxybutyrate. It's mostly made in the liver, the mitochondria of the liver. Why do we do that? Because this is a very portable form of energy, portable form of fatty acid, if you wish, that then they can get out of the liver and reach organs such as the brain that actually can use that energy if they need to. So when does that happen? Well, all right, so if the carbohydrates are low, gluconeogenesis will be up, TCA intermediates will be low. So that's not so good. But if the carbohydrates are low and fatty acid breakdown is up, okay, then the acetyl-CoA will be up. This is when you have a ton of acetyl-CoA, so lots of fatty acid breakdown. This is when you make ketogenesis. Okay, so you don't do this when the TCA cycle intermediates are low. So all right, so how does that happen? We have seen this reaction before, thiolase, but in this case, we're going to discuss it in more detail. So we have two acetyl-CoA molecules. Okay, thiolase will generate acetoacetyl-CoA, and we'll see what happens to that in a minute. But let's look at the acetyl-CoA. It's actually probably the most important part of the ketogenesis, and you will see why. It explains why acetyl-CoA is such a key metabolite. It has some very interesting properties. So here we're going to take the red arrows. We'll go from from top to bottom. Okay, we saw thiolase already working in the reverse reaction, the degradative part. When we saw how the triglycerides were used and so on and so forth. So in this case, okay, so what happens is that the two acetyl-CoA molecules, okay, there is one, and there is a second one that's going to come in. Okay, the first one gets attacked by the sulfhydryl on the protein, on the cysteine on the protein. Okay, and that the reaction will continue. Okay, you get coenzyme A, and then okay, the whatever was attacked on and stays on the enzyme. Now a second acetyl-CoA comes in, okay, and attacks it. So one acetyl-CoA gets attacked by a sulfhydryl, and then, as it is stuck onto the protein, it gets attacked by another coenzyme, and by another acetyl-CoA. So this may sound weird, but that's exactly what you get then in the end. You get the acetoacetate-CoA, and what it does illustrate is that in this case, the acetyl-CoA acts as an electrophile, and in the second case, it acts as a nucleophile. It is this fundamental property of acetyl-CoA. It's very versatile, okay, chemically speaking, to act both as an electrophile and as a nucleophile, exemplified in this biosynthetic reaction, let's say, of thiolase, that makes it such a special and unique molecule, and also explains why acyl thioester is the general currency of all the acyl transfer process. We saw it in the fatty acid breakdown. Everything is not just free fatty acid moving around. There's always an acyl thioester. Okay, we have an acyl-CoA of some sort going through all these processes. So all right, so at this point we got the acetoacetyl-CoA, and then it gets modified a little bit with the HMG-CoA synthase comes in. Another acetyl-CoA is added to generate this HMG-CoA. Okay, so this molecule here, which then finally one acetyl-CoA gets released, and we get acetoacetate. So this is one ketone body. These things are not yet ketone bodies. Now we have the first one, acetoacetate. Spontaneously, that could break down decarboxylate and give you acetone. Okay, if you are fasting or if you haven't eaten too much in a while, this is the characteristic smell in the breath. Okay, of a person that breaks down fat essentially a lot and generates ketone bodies. So that's ketosis. That's a diagnostic marker of ketosis. This is what we're talking about. In another reaction, acetoacetate can also be dehydrogenated be reduced by the hydroxybutyrate dehydrogenase and give you hydroxybutyrate. All three are the ketone bodies that we see in the circulation. And that summarizes this video and all the videos that we discussed about fatty acids and how they are mobilized and broken down.